As a service advisor, you are the crucial link between customers and technicians. Effectively explaining complex automotive issues in an understandable way builds trust and ensures customer satisfaction. One common concern customers raise is difficulty starting their car, especially in cold weather. Knowing what happens during a cold start and discussing potential problems with customers can go a long way to building their confidence in your recommendations. When an engine sits for an extended period, especially in cold conditions, several factors make starting more difficult. According to research, a significant portion of a vehicle's harmful emissions occur during the first 30 seconds of operation. That's why manufacturers have sophisticated systems designed to address the challenges of a cold start. So what happens during a cold start? Fuel mixture enrichment. In older vehicles with carburetors, a choke system is used to restrict airflow and enrich the fuel mixture. Modern vehicles rely on electronic fuel injection systems to achieve the same goal. When the engine is cold, the engine control module, or ECM, injects more fuel to compensate for the fact that cold air is denser and more oxygen is present in each volume of air entering the engine. The more fuel injected into a cold engine, the better it starts and runs when it's below operating temperature. Oxygen sensor warm-up. Oxygen sensors play a vital role in regulating the air-fuel mixture once the engine is running. However, they need to reach a certain operating temperature to function correctly. To speed up this process, most oxygen sensors have built-in heaters. These heaters use pulse width modulated signals to heat the sensor quickly, which is managed by the ECM. Newer AFR sensors have an even larger heater that function in a similar manner. Open loop operation. Before the oxygen sensors reach their operating temperature, the ECM operates in open loop mode. In this mode, the ECM relies on preset parameters and data from coolant, air, and ambient temperature sensors to determine the correct air-fuel mixture. Some vehicles will warm up the catalytic converters at the same time. Ignition system enhancements. Modern ignition systems also contribute to improved cold starts. By controlling individual ignition coils, the ECM can optimize timing and spark intensity to promote combustion even in cold conditions. Engine coolant management. Some systems regulate the flow of coolant in the engine block and head to minimize cold start emissions. Other systems may use coolant stored in a thermos-style container to speed up the warm-up process. Here's what to share with your customers to answer some common complaints. Slow cranking. A slow cranking engine could be due to a weak battery, corroded battery terminals, or a faulty starter motor. Cold temperatures can significantly reduce battery performance. Engine hesitation or rough idle. During a cold start, the engine operates in open loop mode, relying on preset parameters. If the engine isn't getting the correct fuel mixture, or if an oxygen sensor is slow to warm up, it can lead to hesitation or a rough idle. A vacuum leak or faulty sensor could also be the culprit. Check engine light. The check engine light could indicate a variety of issues, from a malfunctioning sensor to a problem with the fuel injection system. We'll need to perform a diagnostic scan to determine the exact cause. Fuel smell. A fuel smell could indicate a fuel leak or an issue with the fuel injection system. It's important to address this promptly, as it could pose a fire hazard. Extended cranking time. This can happen when the ambient and engine temperature are below the normal operating temperature. When this occurs, it often takes more than 1 or 2 attempts to start the vehicle. Depending on engine size, the battery could be exhausted when the driver persists, and the vehicle may have to be jump-started. For techs, here are typical steps when diagnosing a cold start issue. Check for diagnostic trouble codes related to the engine, fuel system, or sensors using a scan tool. Evaluate the functionality of engine sensors, coolant temperature sensors, and air temperature sensors. Check fuel pressure, fuel injector performance, and the presence of fuel leaks. Assess spark plug condition, ignition coil performance, and wiring integrity. Rule out any mechanical issues, such as compression problems. Review this data to identify the conditions present when a fault code was stored. By explaining the complexities of a cold start in a clear and concise manner, you can build customer confidence and demonstrate your expertise. Emphasize the importance of a thorough diagnosis to accurately pinpoint the root cause of the problem. Assure customers that your technicians have the knowledge and equipment to resolve cold start issues effectively. For more information, visit shopsquadonline.com.